Bismillahirrahmanirrahim. This video is from Power Electronics, and here we'll be discussing half-wave rectifier. And there is an assignment question that we'll primarily solve. This is very important that you watch this because this gives some very educative knowledge which will help you in power electronics. Okay, so we start with the single-phase half-wave rectifier. We know that the input is a sinusoidal signal of an half-wave rectifier, and the output is only half of the way, either positive or negative. This we all know. But now the confusion starts here. The book says we write the half-wave rectifier output voltage as V out, this voltage as VDC plus VAC. Now DC you can understand that this is in one direction, that could be DC, but where from AC comes. So for that, I had to then do a little more research, and I finally found this analysis. A Fourier analysis of half-wave rectifier output, load current. Now this is voltage and this is current, it doesn't matter as long as we understand. So the Fourier analysis of the current says that the load current would consist or will make with this equation where we have this term not dependent on time. That means this is the DC component and these are the AC components or the harmonics of sinusoidal signal. Basically, these are the low frequency unwanted AC components or the ripple components, which apparently we can't see here, but this is present when we analyze this signal through the Fourier analysis. So we have VDC and we also have VAC. And similarly, we'll have DC power at the output and also we'll have an AC power at the output. And for DC power, and to just isolate that we are talking of the output area, I've just written O here. So P output DC is VDC, IDC or VODC. So this voltage VODC that we are talking here, VDC, and the current IODC. And similarly, P out AC is VO RMS and IO RMS. Here the RMS value or the AC value. Okay, now if you look up to this diode, we have the AC signal applied, and after this diode, this becomes only one-sided or pulsating DC. If we draw a line across the diode and divide it into two parts, this part will have VRMS here, and this VRMS can be written as V maximum divided by under root 2. We know that the RMS is peak divided by under root 2. So this formula is applicable here. But the formula changes on this side, and here for VODC, we'll have Vm over pi. This is for half-wave rectifier, we know. But this is something new that I have learned, that is VORMS. On this side will be now Vm over 2. Remember, this and this are different. This was divided by under root 2, and here it is divided by 2. On the DC side, when we calculating the output RMS, you have to remember this. It is Vm divided by 2 or 0.5 Vm. And if you want to look at it, this is VODC, 0.31 from the peak, and VORMS is 0.5 from the peak. Now, coming on to the question number 1. For the half wave rectifier with a resistive load of 5 ohm with Vs 120 volt, determine these three parameters. The first thing you have to keep in mind that when we say it is 120 volt, that means we are talking of RMS voltage. Like in our household, when we say it is 220 volt or 120 volt, then we mean it is RMS voltage. So I'm just writing it here, RMS. And so here instead of sign, we'll now write Vs 120 volt RMS to solve this question. And the first thing that we must find Vm. Why? Because you can see these all depend on Vm. VODC depends on Vm, VORMS depends on Vm. And where from we can find Vm is from here. We know the RMS value is given. So using this formula, we can find Vm. So Vm will be under root 2 VRMS is under root 2 into 120 is equal to 169.7 volt. I'm just writing peak, that is the maximum value. Vm we have known, and now we can find the first, that is the average load current or the DC load current. For that we need to find the DC voltage first. VODC is Vm over pi, 169.7 over pi. So this is 54.02 volt. Now VODC is 54.02 volt passing through R will give us IODC. So IODC is VODC over R, 54.2 divided by 5 is 10.8 ampere. So the average current is 10.8 ampere. The first part is done. Now coming on to the part B, the power absorbed by the load. And we had seen that there are two powers, PDC and PAC. We had also found these VODC, we had found IODC, and we have found VM. So now we'll just use the formula PODC as VDC IDC or VODC into IODC, and putting the values from here. The DC or PODC is 583.4 watt. Now coming on to POAC, we have VORMS and IORMS, and for that we need to find VORMS by using this formula. So VORMS is Vm over 2, and 169.7 divided by 2 is 84.85. And now IO, same formula. If we are applying a VORMS, then IORMS will be VORMS divided by R, which is 5. So IORMS is 16.97 ampere. We can approximate it to be 17 ampere. So power AC, VO, the same formula that we are using, putting the value now, 4 and 16.97. So this is 1439.9 watt. Now note that this is in watt. DC was in watt, but POAC because this is the power spent across the resistor. So it is in watt. Now the third was the power factor of the circuit. For power factor, we will see this power triangle diagram, and you can see this is called the apparent power, which can be written as VRMS, IRMS, and this is the real power and imaginary power or reactive power. We will use as this, that we know that cosine theta is base over hypotenuse. So cosine theta is P over S, where P is the real power and S is the apparent power. So using this, we can find cos theta to be P over S, and now PAC we'll be using here because this is related to angle theta, and angle theta is also, we know, the angle between voltage and current, and also it is the impedance angle. So PSC load, and then S, this one is VA of the transformer, or VA rating of the transformer, we say, which is same on the primary and secondary side. You can also write this to be VRMS IRMS because we know this value. So VRMS IRMS. Now S is here for the secondary RMS voltage, and IS is the secondary RMS current. Now POAC we already know. VS RMS is given 120 volt, to recall the figure. And also IS RMS is same as IU RMS. Let's see from here. See this diagram. This is the secondary current, and it is the same current throughout the circuit. This same current. So IS transformer, or IS, is IS load or IO load. So IS is 16.97 that we found, IO. And now we can put this value, POSC we know, VS RMS is given, and IS RMS from here is 16.97. And so the answer is 0.707. So I hope you have been able to follow this. Please let me know through your comments. Thank you.